Okay, so we have, so far with quadratics, we have solved quadratic equations. Now we're going to start graphing quadratic functions. Okay, so just like a quadratic equation standard form, a quadratic function in standard form would be y equals ax squared, so something x squared plus something x plus bx plus some constant c. Okay, when you have an equation, this is set equal to 0. When you're graphing, it's set equal to y. Okay, and the graph of a quadratic function, which you see over here, is called a parabola. Okay, parabola is a U-shaped curve. Okay, so parabolas can open upward like the graph you see below, or they can look like that. They can open downward, okay? So the graph opens upward if a is greater than 0. A is the leading coefficient, okay? Opens downward, so if a greater than 0, in other words, if the equation starts with a positive leading coefficient. Okay. And so if you see if it starts with like y equals 3x squared plus whatever, then it's going to open upward. It's going to open downward if the leading coefficient, or a, is less than 0, which means a negative leading coefficient. So if it started with y equals negative 3x squared, it's going to look like that, okay? All right, other important information about graphs of a quadratic function. Quadratic functions have what's called a vertex. So our vertex point of the one you see on the screen is right there. So it's either your low point, your minimum, or if the graph opens downward, your vertex, like over there, this would be a high point. We call it a max. Low, we call it a minimum. Okay? So the vertex of a parabola are the coordinates of the graph where it is at a maximum, a high, or a minimum. Okay, so this minimum over here represents the lowest point on the graph. This high, this maximum, represents the highest point on the graph. All right, let's see, what else? So parabolas have a symmetry to them, okay? Meaning, if we drew a line, I'm just gonna draw it with a dashed line over here, the parabola is symmetric with respect to this line, respect to a line drawn through the middle, through the vertex. Okay, so axis of symmetry is the line that divides the parabola into two mirror images, okay? And that's going to be important when graphing them, okay? X-intercepts. X-intercepts are the point where the parabola intersects the x-axis. So x-intercepts here would be over here and here. It's where the graph hits the x-axis. Okay, so some of the questions you're going to have to answer in your assignment look like this, where you're going to, before actually graphing anything, they're going to give you a graph and you're going to have to answer questions about that graph. Okay, does the parabola open upward or downward? Of course, this one opens upward. Find the equation of the axis of symmetry. Okay, so let me erase this actually. So we see that the parabola has its symmetry. I want to be able to see the numbers at -4, okay? So it's a vertical line that is intersecting -4, right? It's intersecting the x-axis at -4. So this is the equation x equals -4. All right, you should remember vertical lines begin with x equals. Horizontal lines begin with y equals. Find the coordinates of the vertex. So the vertex is over here. What are the coordinates? The coordinates there are -4, comma, -2. Find the intercepts. Okay, so they want y-intercepts as well. So the x-intercepts, we forgot to put this in your notes. So y-intercept, of course, it's going to be where it intersect the y-axis. So the x-intercepts are -6 and -2. Okay, the y-intercept is +6. All right, so let's go through how to actually graph a parabola. Okay, so step one, we have to find the coordinates of the vertex. We have to know where that high or low point on the parabola is going to be at. So to find the vertex, first thing you need to do is use this formula, x equals -b over 2a. All right, so in this example, remember a is over here, b is over here, c is over here. So a equals 1, b equals -4, and c is -1. Okay, it's helpful to write that out. So we're going to use this to get the coordinates of the vertex. So to get the x part of the coordinate, x equals -b over 2a. So we have -4, which is +4, over 2 times 1, which is 2. Okay, so the x bar of the coordinate is 2, of the x bar of the coordinate of the vertex. Now we need the y part. So to find the y, substitute x. So meaning into here, into our equation, I'm going to substitute 2 to get the y. So y is going to be 2 squared minus 4 times 2 minus 1, so that's 4 minus 8 minus 1, which is -5. So the vertex is 2, -5. Okay, step 2, plot the vertex you found step 1. So let's put that point on the graph. 2, -5 is over here. All right. Now, step 3, we're going to plot 2 points on each side of the vertex using a table of values. Okay, here's what that means. I'm going to make a chart. X, y equals x squared minus 4x minus 1. Okay, so we want 2 points on each side of the vertex, all right? So I'm going to do the right side first, and then once we have the right side, we're not going to need to do anything to get to the left side, because we know that we have, from the vertex, we have that mirror image. So if I know the right side, I can get the left side by using symmetry. Okay, here's how that works. Okay, so again, I'm looking for x values. So the coordinates of my vertex, the x value is 2. So I'm going to use 3 and 4, the next 2 to the right of our vertex. Okay, so we're just going to evaluate. We're going to substitute here. So the y is going to be 3 squared minus 4 times 3 minus 1. So that's 9 minus 12 minus 1, which works out to -4. Okay. And then for 4, it's going to be 4 squared minus 4 times 4 minus 1, which comes out to 16 minus 16 minus 1, which is negative 1. Okay, so we have the point 3 comma negative 4. Let's plot that. That's over here. And then 4 comma negative 1. That's over here. All right. So this is the right side of my parabola. Well, we know the other side's going to be the mirror image of the right side, again, because, let me show you again, this vertex over here creates that symmetry. So we know that one right of the vertex is at negative 4. So one left of the vertex also has to be at negative 4. 2 right of the vertex is at negative 1. So 2 left of the vertex also has to be negative 1. Okay? And then, I didn't draw that so well. There we go. Okay, so what we did, we plotted 2 points on each side of the vertex using a table of values and symmetry. Okay, and then we connected with a smooth curve to make our parabola. Let's try another one. Okay, y equals 3x squared plus 6x minus 2. So let's get the vertex. So to get the x, we're going to use x is negative b over 2a. Let's identify a, b, and c. A is 3. B is 6. Not that we need c, but c is negative 2. All right, so negative 6 over 2 times 3, which comes out to negative 1. Okay, now to get the y, we're just going to substitute. That's going to be 3 times negative 1 squared, be careful here, plus 6 times negative 1 minus 2. It's going to be 3 times 1 minus 6 minus 2. So that's 3 minus 6, negative 3 minus 2, negative 5. So the vertex is negative 1, negative 5. Let's plot. That's right there. Okay, and we should also note that because the leading coefficient here is positive, we know it's going to open upward. Okay, not really necessary, but again, we know if this started with a negative 3, it would open downward. All right, so we know the vertex is at negative 1. I'm going to get 2 points to the right of that. Let's make a table. So the vertex is at negative 1. Let's do 0 and positive 1. Zero works out very nicely. Okay, we can forget this and this. That's just negative 2. Okay, so we have the point 0, negative 2, which is over here. And then we have, let's get 1. Okay, so that's 3 plus 6 minus 2. So that's 7. So we have the point 1 comma 7. Okay. So this is the right side of the parabola. Let's get the left side by symmetry. We know 1 to the right of the vertex is at -2. So 1 to the left of the vertex also has to be at -2. 2 to the right of the vertex is at 7. So 2 to the left of the vertex also going to be at -7. Okay, we have our points. And we're going to finish by plotting a smooth curve.